Hey everyone, Math 100. We're working on sections 1.7 and 1.8 today. Rounding, estimating, and applications. So, suppose that a member of the Green Bay Packers management would like to estimate the attendance of all the home games during a season. So you can see in the table there, we've got a list of all the home games and the attendance. So we could go through and just add up all those numbers and get an exact answer. But we just want an estimate. So it'll be a lot faster to round each of those numbers and then add them together. So rounding is keeping the important digits and turning all the unimportant digits into zeros. So for example, if we got a number between 100 and 200 and we want to round that to the nearest hundred, we're going to find the two basically 100 values that surround the value. So at 120, the 200 values that are closest are 100 and 200. And so since 120 is closer to 100, we would round 120 to 100. 170 is closer to 200 than 100, so we take 170 and round to 200. So that's the basic idea of what's going on. Let's take a look at the procedure. So first thing we're going to do when rounding a number is find the round digit. That's the digit that we're rounding to. Now the decision digit is going to be the digit to the right. So we're going to have to look at that and figure out what we're going to do with the rounding digit. So, if the digit to the right of the round-off place is less than 5, then we leave the rounding digit alone and turn everything else to the right to zeros. Now, if it's 5 or greater than, what we're going to do is raise the rounding digit by 1 and then turn everything to the right into zeros. So let's take a look at an example of that. We're going to round 102,785 to the thousands. So first thing we're going to do is identify the rounding digit. So a thousands place is 1, tens, hundred, thousands. So 2 is the rounding place. Now the decision digit is going to be the one to the right. And this is the one we have to look at to figure out what we're going to do with the 2. So the 7 is 5 or greater. That means we're going to add 1 to the 2, so 2 turns into 3. So it's going to be 103. And then all the digits to the right of the rounding digit turn into zeros. So the nearest thousand is 103,000. All right, your turn number 1. For A, round 5109 to the nearest 10, and 1,583,298 to the nearest 1,000. All right. Nearest 10 is, that would be the 0. So we're going to look to the right of that. The 9 is 5 or greater, so that means we're going to add 1 here. So that'll be 511, and everything to the right turns into zeros. 5,110. Next up, to the nearest 1,000. So we're going to identify the rounding place. That's the 3. Now we'll look to the digit to the right. That is less than 5. So we leave the rounding digit alone. We're going to leave it as 3. So that's 1,583,000. And then everything to the right of that turns into zeros. Now there are times when carrying will be required. Just like when we're adding. So we're going to round this one to the nearest 100. The rounding place is the 6. Oops. Rounding place is the 9. And we're going to look to the 6 to decide what to do. So 6 is 5 or greater, so that means we need to add 1 here. But that turns the 9 into 10. So we're going to carry the 1 over to the 4. So that becomes 5. So we get 3, 5, 0, 0, 0. 35,000. So even though we're rounding to the nearest 100, it kind of looks like rounding to the nearest 1,000 because this thing turned into a 0 by adding 1 to it. But really, we're rounding to the nearest 100 here. All right, your turn number 2. Round 1,398 to the nearest 10. Nearest 10, we got a 9 there. Look to the right, that is 5 or greater, so we're going to add 1 here. That turns into 10. Carry the 1 to the 3. So 1, 1400. So let's put these rounding skills to work with the principle of estimation. So when we're going to estimate it, we're going to round each number in the operation to the leftmost digit. So we should have only one non-zero digit after we round. And then we're going to add them together. So for the example, we're going to estimate the sum of 2351, 6732, 1153, and 3689. So first thing we're going to do for estimating the sum of these is round each one. So we're going to round to the leftmost digit, so we're rounding to the thousands in each case. All right. This little squiggly here, this means approximately equal to. So to the right of the 2 is a 3, that is less than 5, so this stays 2,000. All right, 6732, 7 is 5 or greater, so that increases this to 7, so we get 7,000. Here we got a 1, that does not increase the 1, so that stays as 1,000. And this one we got a 6, that is 5 or greater, so that turns into a 4. So there's our 4 rounded values. Now add these up. 7, 11, 12, 13, 14. 14,000. So if you just need a quick estimate, this is the way to go. Okay, now let's see where this is really useful and how you can use it on an exam. So, on an exam, a student divides 24,288 by 23 and gets an answer of 10,560. Well, let's estimate the answer to see if this result is plausible. This is a good way to trick your work, especially if you tend to make off by, let's say, the decimal points off by one place sometimes. Great way to catch these. So we're going to do 24,228 and round that, and we're also going to round 23. So both of these will round to the leftmost digit. So we got a 2. 4 to the right is less than 5, so that's going to stay at 2, and this rounds to 20,000. And then 23, 3 is less than 5, so that stays 20. So what we're going to do is take 20,000 and divide by 20. You can do this long division. As it turns out, there's a quick way to do it. We got this 0 here and 0 here, so we'll just ignore those, and we'll do 2,000 divided by 2, which is 1,000. So that means 20,000 divided by 20 is 1,000. Now, is that anywhere close to our answer of 10,560? No, it's way off. So that tells us we probably made a mistake then on the division. All right, your turn number 3. Estimate the product of 2956 and 315, and then we'll compare with the actual value of 931,140. All right, 9 is 5 or greater, so this will round to 3,000, and 315, 1 is less than 5, so that stays at 3, and we got 300. So we are going to divide 3,000, or multiply 3,000 by 300. All right, we got 3 times 3 is 9, and we got 1, 2, 3, 4, 5 zeros. So 900,000. And the actual value is 931,140, so pretty close. Part B, now let's go back to the beginning. We're going to estimate the Green Bay Packers total home attendance for the 2018-2019 season. All right, now when we round these, notice each one of these is going to round to 80,000. So you can either add those up or just multiply by 8. So the attendance 640,000 fans for the year. And that's probably pretty close, but if you look at all these values, we had to round each one of these up. So that's going to give us a little bit of an overestimation. So that's the downfall of this, or I should say drawback of this approach, is if you have to round them all in the same direction, you're going to get an answer that's a little bit off. But it's not too far off. Actual attendance is probably off by about 10,000, 15,000, so that's not too bad. Next up, applied problems. So the procedure we're going to be using, make sure you read the problem carefully and pick out all the numerical information. And make sure you keep units with them. And take a look at any of the mathematical keywords that we've encountered so far. Things like, per for division, and so on. Draw a picture of the situation if it helps you see the relationships more clearly. And then we're good between A and B, that allows us to determine the mathematical operations that we're going to be required to solve the problem. All right, now, once you do the calculations, state the answer including the units and a short sentence. Just tell them what we're talking about. And then check, make sure you estimate the answer. We're going to use the principles of estimation to see if our answer is close. So first example, Donna bought 45 shares of stock for $16.20. How much did stock cost per share? All right, so we're going to read this problem carefully, pick out the values. So we got 45 shares, and total is $16.20. Keyword is per. All right, so per indicates division. So what we're going to do is we're going to take 1620 divided by 45. All right, 45 does not go into 1 or 16, but it does go into 162. It's going to go 3 times. All right, 3 times 45, 135. Subtract that. Get 17, bring down the 0. Whoops. Knew I made a mistake there. Okay, 270. So now 45 is going to go into 270 6 times. You get 0. So 36, we got 36 shares of stock. All right, so our answer, numerical answer, here the unit is our shares, and what are we talking about? Stocks. Okay, so now let's do an estimation. So if you're around 1620, that rounds to 2,000. All right, 6 is greater than 5, greater than or equal to 5, so we increment 1 by 1, turn it into 2. All right, 45 shares, 45 rounds to 50. All right, 5 or greater, raise 4 by 1. Now we're going to do 20 divided by, or 2,000 divided by 50. That gives us 40. So 40 is pretty close to 36, so that confirms. Your turn, number 4. Cloud storage company charges $2,232 to store 72 terabytes of data for 1 year. At this rate, what is the cost of storing 1 terabyte of data per year? So we got $2,232 and 72 terabytes. All right, per indicates division. So let's try doing 2232 divided by 72. All right, 72 doesn't go into 2 or 22, but it does go into 223. That'll be 3 times. 216, subtract to get 7. And it goes in once. So that means each terabyte cost. All right, numerical answer with units, dollars, $72. And what are we talking about? We're talking about cloud storage, so for 1 year of storage. All right, let's estimate, see if we're close. So 2,232, that rounds to 2,000. And 72 rounds to 70. So this will make our division a little easier. This will go in 2 times, 140, subtract to get 60, bring down the 0, we got 600, and 7 times, we got 8, 560, 28 point something, which is pretty close to 31, so that works. Your turn, number 5. A homeowner is renovating a house to make it more energy efficient. They must pay $1,538 for materials and $384 for some help from a contractor. After they complete the project, they receive a tax credit of $937. What's the total cost of the project? All right, so let's break this thing down. We have things we have to pay, our costs. We have $1,538 and $384. All right, so let's find our total costs. Add these together, get 12 here, carry the 1. Another 12, carry the 1. That gives us a 9 and 1. $1,922 in total costs. And we have a $937 tax credit. So we can deduct that from the cost. So we're going to take $1,922 and subtract $937. Probably the biggest mistake I'd seen on a problem like this is someone just adding all three things together, not realizing that two of them are costs and one of them is income. Okay, so let's subtract here. Let's see, we're gonna have to borrow. Right, that gives us 12 minus 7. All right, and we have to borrow again, so you got an 8 here. That turns into 11. 11 minus 3 is 8. And then 18 minus 9 is 9. All right, so that's the total cost. Okay, so let's estimate here. Here we got 19, wait, no, we'll do these. Their original values. So 1538, this is going to round to 2,000. 384 rounds to 400. Add those together to get 2,400. Down here, 937, that will round to 900. So subtract 900, that gives us so we have by 400. Yeah, that's all right. Okay. So we subtract that, we get 1,500. That's pretty far off from our estimate, but that's what happens when we round something like 1,500 to 2,000. We're actually adding 400 on that one. And so we got something that's quite a bit off. But it's not off by like an order of magnitude, which is like moving the decimal point. It's not like we got an answer of 98.5 or 9,850. That would have been a big warning sign if we estimated that and compared with those. But with this one, yeah, we're off by quite a bit, but it's going to happen sometimes if you've got these roundings. If this happens, it might be a better idea to go ahead and round this one to give you one more digit here and round this one to the nearest 100, and then we would have been a lot more accurate. So if you get something that's a little weird like that, try just doing a little different rounding. So next example, we got a group of friends going out to dinner. They're buying 3 appetizers for $5.50 each, 4 entrees for $10.25 each, and 6 drinks for $1.25 each. How much was their bill? Okay, so three appetizers, 4 entrees, $10.25, and we got 6 drinks. $1.25. So what we're going to need to do is find out the total cost of the appetizers, the total cost of the entrees, total cost of the drinks, and then finally add them all together. All right, so we've got things that are the same price, and we know the number of them. So in that situation, it is multiplication. So we're going to start by doing 550 times 3. We got 1025 times 4. 125 times 6. All right, so we're going to multiply these out. All right, now we will add these all together. So the total cost of the meal was $65. All right, now if we're going to check, we should round these to 6, these to 10, and these to 1. All right, now we got 6 times 3 is 18, 10 times 4 is 40, 1 times 6 is 6. Add these all together, we got 40, 58, 64. So that's pretty close. Your turn, number 6. The organizers of a cross-country meet bring water to the race. There are 4 cases of 24 bottles, 6 cases of 12 bottles, and 8 cases of 6 bottles. How many bottles of water do they have for the runners? We have 4 cases of 24, 6 cases of 12, and 8 cases of 6. So to solve this one, we're going to have to figure out how many total bottles we have in these cases of 24, how many total bottles we have in these cases of 12, and then how many total bottles we have of these cases of 6. All right, so each case has 24, it's the same amount in each one. We know the number, so we'll multiply those together. So we got 24 times 4, 96. And then we'll do 6 cases of 12, so that's 12 times 6. That gives us 72. And then 8 times 6, 48. Now we'll add all these together to get the total. 10, 16, carry the 1. We got 10, 17, 21. So they brought 216 bottles of water. All right, now if we round with those multiplications, with low numbers like that, it just doesn't really work. So let's just round with these values instead. So if we round this to 100, 70, and 50, 100 plus 70 is 170 plus 50 is 220. So pretty close. Your turn, number 7. Diana owns 85 acres of forest land in Oregon. She rents it to a timber grower for $250 per acre. Her property taxes are $4,250. What is her total profit? All right, so the income is what we're going to get from the acreage. 85 acres, $250 per acre. So 85 acres at $250. And then the cost are the taxes, $4,250. Okay, so to find the total income, we've got the same price coming in for each acre, so that means we can multiply. So we take 250 multiplied by 85. So we got 0 times 5 is 0, 5 times 5 is 25, carry the 2, 2 times 8 is 16, plus 2 is 18. All right, second row, so add a 0, 0 times 8 is 0, got another 0 there, 5 times 8 is 40, so another 0. And carry the 4, all right, so I see you open the second row of carry digits, 2 times 8 is, made a mistake here. I multiplied by the wrong digit. That's supposed to go 2 times 5 is 10 plus 2, so that's going to be 1250. Okay, continuing on to the second row, we got 8 times 2 is 16 plus 4 is 20. Okay, adding those together, we got 2, 1, 2, 3, 4, 5, 2, 1. $21,250. All right, so that is the total income. Now we have to deduct the cost. So we're going to take 21,250 minus 4,250. 250 minus 250 gives us all the zeros here. And 21 minus 4 is 17. So the total profit is $17,000. All right, let's check. We're going to round these first. 250 rounds to 300, and 85 rounds to 100. Multiply those out, we get 30,000. 4,250 rounds to 4,000. Subtract 4,000 from that, and we get 26,000, which isn't that close, but at least it's not off by an order of magnitude. So if you want to check that a little closer, we could round the 250 to the tens digit instead, and that would get us closer. Your turn number 8. After a trip, the driver would like to calculate the gas mileage of the vehicle. The initial odometer reading was 29,748 miles. And the final odometer reading is 30,300 miles. Total fuel consumption for the trip is 23 gallons. What is the gas mileage in miles per gallon? So we have an initial odometer reading and a final odometer reading. What we want is the difference between those two, and that is subtraction. So we are going to take $30,300 and subtract the initial reading, 29,748. When you subtract like this, make sure the smaller number always goes on the bottom. Subtracting, we're going to borrow here. 10 minus 8 gives us a 2. 9 minus 4 gives us a 5. 2 minus 7, can't do that, so we'll go over here and borrow from here. 12 minus 7 is 5. All these are zeros, so 552 miles. Now, Total fuel consumption was 23 gallons. What is the gas mileage in miles per gallon? Or per is division, so we'll take 552 and divide by 23. So 23 will go into 55 two times, giving us a 46. Subtract. Got a 9 and a 2, and that's going to be 4. So the vehicle gets 24 miles per gallon. Units are MPG. Okay, how about if we round 552 to 600 and 23 to 20. Divide and we get 30. And that's pretty close to 24. Your turn, number 9. A carpet cleaner rental company has 3 locations. Over the course of a week, they rent out their machines 12, 18, and 13 times at the 3 locations. If the company charges $48 for each rental, what's the total income from all of the rentals? So we're going to need the total rentals. So total is additions. We got 12, 18, and 13. Add those together. We got 2, 8 is 10, 3 is 13, carry the 1. So 43 total rentals. And each rental brings in $48. Alright, so they're all the same price. That means we can multiply. 48 times 43. 8 times 3, 24, carry the 2. 4 times 3 is 12, plus 2 is 14. And here we got 8 times 4 is 32, carry the 3. 4 times 4 is 16, plus 3 is 19. Add those together, we got 2064. So the total income is $2,064. All right, so let's check. The income we could round 50 and 40, multiply, and we get 2,000. Very close. Your turn, number 10. A theme park charges $28 for adults and $12 for children. A family of 2 adults and 4 children spend a day at the park and spend $23 on food. What's the total cost of the trip to the park? All right, 2 adults at 28, 4 children at 12, and 23 on food. So the adults are the same price, so we can multiply. So that's 28 times 2, or 56. Same thing with the kids. We can multiply here. 12 times 4 gives us 48. All right, so it's the price then is 56 for adults, 48 for kids, and 23 for food. So we'll add all three of those together. So you got 14, 17, carry the 1, 10, 12. Total cost was $127. All right, let's check. So 56 rounds to 60, 48 rounds to 50, 23 rounds to 20. Add them all up and we get 60, 50, 110, 130. So very close on the estimation. Your turn, number 11. 3 college students are selling t-shirts outside a football game. They bring in $296, and the t-shirts cost $62 to make. And they're going to share the profits equally. How much money does each student make? All right, well, let's figure out the profit. I give you the equation, profit equals revenue minus cost. So the revenue was $296, and the cost is $62. So subtract those. So they made $234. And there are 3 college students. And so we're going to figure out how many each one made. So we're going to split this evenly between the 3 students, so that is division. So 234 divided by 3. All right, that's going to be a 7 here, 21. Subtract to get 2. Bring down the 4. And get an 8. So each student made $78. Now we could check this one. It's not a very good check because we're just going to round 234 to 200. Divide by 3 again and get 66. It's pretty close. All right, so when you're working on these, make sure you do this check. If you want to do the check with a calculator, that'll make it even faster. It's a good thing to do. You catch major mistakes that way. All right, everyone, that's it for today.